Hello, this is Mrs. Taylor, and I'm going to walk you through how to find some of the characteristics of a graph. So the characteristics we're going to go over are the x-intercept, the y-intercept, your relative max, relative min, that's maximum and minimum, and then my interval of increase, or intervals, it could be multiples, and then intervals of decrease, and your intervals, let's say positive intervals, and your negative intervals. So these are all some characteristics of a graph that can be helpful to communicate how the graph is behaving. If someone couldn't see the graph, they might want to know this information. And so to start with, let's talk about your intercepts. Intercepts are where the graph crosses an axis. And so that means that the x-intercept is where the graph crosses the x-axis. And when I look at this graph, I see three places. It crosses the graph, or excuse me, it crosses the x-axis here, here, and here. And there's a couple things I have to be really careful about. First thing is, make sure you pay attention to scale. So are these lines actually 1 unit, 2 units, 3 units? What's the scale? And if I look, they've marked every second line, and it looks like the one in between is a unit of 1. So 1, 2, 3, 4. So before you determine any of this information, you first need to look at the scale, because sometimes it can be tricky. And then also with graphs, anytime you use a graph, it's an estimate. And so even though our points here are not perfectly on a whole number, it's okay to estimate approximately where it is. And so your x-intercepts are the places where it crosses the x-axis. And some of these aren't whole numbers, so we're going to estimate where those are. And when you list your x-intercepts, you have two ways you can do that. You can just say x equals, and then whatever the numbers are, or you can use coordinate notation. So I'll show you both. So this first x-intercept right here looks to be almost at -3. So let's say -2.9. And then this one here looks almost at 0, so let's say -0.1. And then it crosses here at x equals, I would say that's at 3. Okay, so that's what it would look like if I just listed my x-intercepts. Now if I wanted to use the coordinates, I would need to remember that the x-intercept is where y equals 0. So if I entered this first intercept at x equals -2.9, my x value would be -2.9, but my y value would be 0. And then my next intercept would be -0.1, and my y value again would be 0. And the last one would be at 3, 0. So that's how I could list my intercepts in coordinate notation. Y-intercept, let's see, it only crosses the y-axis in this one place right here. And I would say that's at y equals -1. So again, I can just write it as y equals -1. Or again, I can use the coordinate notation. And y-intercepts are where x is 0. So my coordinate notation, the 0 would go in the x's place. And then my -1 would go in the y's place. So that's x-intercept and y-intercept. Done. Okay. Alright, so next we have relative max and min. And when I went over this in class, the way I described the max is up the top of your hill. So if you imagine this as sort of like a mountain landscape, a relative max is the top of a hill. Another way to describe it is it's where your curve changes from increasing to decreasing. And so that happens at this one point right here. This would be a maximum, a relative max, because it's relatively the highest point on the graph. And your maximums and minimums are your y values. So if I just asked you to name the maximum, you would give me the y value, which I would estimate to be 7.7. And so if I was just wanting to list the relative maximum, I would just say 7.7. However, you may want to give the actual coordinates, so you would need the x value, which looks to be negative 1.5. So negative 1.5, 7.7. Those are the coordinates of the maximum, but the actual maximum is the y value. So again, either of these answers would be acceptable. And then my minimum, well, the minimum is sort of your valley. I think that was the word I used to describe it in class. It's also where the graph changes from a decrease to an increase. And so it would be this point right here where it changes direction. And that looks to be at approximately negative 9.5. So if I asked you for the minimum, it would be the y value, which is negative 9.5. But if you wanted to give the coordinates, that's fine too. So let's see, what's the x value there? I would say 1.5. So 1.5, negative 9.5, that's your coordinates of your relative maximum. And so your relative minimum. Maximum is the top of your hill. It's where it changes from increase to decrease. Relative minimum, it's in the valley. It changes from decrease to increase. So let's move on to intervals of increase and decrease. So if we're still using this top of the hill valley reference or analogy to describe these different characteristics, an increase would be as you were climbing uphill. Another way to think of it is your y values are increasing as your x values increase. So an example of an increase on this graph would be along this section of the graph. It's traveling upward, uphill. As you move left to right, your x values are increasing, and it's going upward, so your y values are increasing. Another section where this curve is increasing is this one here. It's moving uphill. And you see how it travels off the side of the graph. We are to assume that it will continue behaving in that way infinitely if it goes all the way to the edge of the graph. And so it doesn't just end here, it continues downward and continues upward. And so that is really important when you're talking about intervals, because when you note the intervals, it's about where it begins and where it ends. And so if it's not ending, that's infinity or negative infinity. So intervals of increase, one thing that we need to remember is if it's the leftmost section of the graph, like this interval right here, we're describing intervals left to right. So if it's the leftmost section of the graph, we start that interval with negative infinity because it's moving infinitely to the left, which is in the negative direction. And so this interval I would describe as negative infinity all the way to here. And you may be tempted to name the y value, but we describe intervals in terms of x. So the x value for this point is negative 1.5. And so my interval of increase would be negative infinity to negative 1.5. Again, we're using the x values. So it's infinitely to the left, negative infinity, and then ends right here at this maximum, and that is at x equals negative 1.5. But we had two intervals, so I need to describe the other one, which is this one here, and it starts here at this minimum, and that would be approximately, where do we name the minimum? At 1.5. The x values, remember that's what we're looking at. And then it continues infinitely to the right. It's the rightmost piece of the graph. And so if it's the rightmost piece, and we're talking about intervals, we describe that as we describe that as positive infinity. And so it starts at 1.5 and travels to positive infinity. And so my two intervals of increase would be negative infinity to negative 1.5, so this left section here, and then 1.5 to positive infinity, this right section here. And that leaves this one piece in between, which would be your interval of decrease. It moves downhill. And it's sandwiched between the two increasing intervals. So its x values should match up with the two x values here for my interval of increase. It travels from negative 1.5 to positive 1.5. And so my interval of decrease would look like this. One thing to keep in mind when we're talking about intervals of increase and decrease and positive and negative intervals, we always use parentheses. We do not use brackets for these intervals. Because if you think about it, at this one point, it's neither increasing or decreasing. It's the point where it changes direction. So we can't include those x values. Alright, last thing, positive and negative intervals. Positive and negative intervals, that's referring to the y values. So, positive is where you have positive y values, and negative is where you have negative y values. So if I am looking at my graph, really what I'm looking at is the top half and the bottom half. All the positive y values are above the x-axis. So this part of the curve has all positive y values. It's above the x-axis. And this part of the curve has all positive y values. So it's also above the y-axis. And so when I name my positive intervals, I'm going to have 2 because I have 2 pieces of this curve above the x-axis. And again, I'm using the x values to describe the intervals. So this one piece here starts at x equals approximately negative 2.9 and then travels to this point, which is approximately negative 0.1, and if you look, those numbers match up with the x and the y intercept here. So my first interval would be negative 2.9 to negative 0.1. And then I have this next piece here that's above the x-axis. It starts at x equals 3, and that also happens to be my last x-intercept. And it continues infinitely to the right. It's the rightmost piece of my graph. So and any time you have the rightmost piece, your interval will end with infinity, just like here. And so it starts at 3 and travels through infinity. And it's positive infinity because it's the farmost right. So my intervals would be, for positive behavior, would be negative 2.9 to negative 0.1 and 3 to infinity. Alright, so last thing is negative intervals, which are the parts of the graph below the x-axis. So this one piece here, and then from here to there. Those are the halves underneath the x-axis. Those are my negative y values. And so to describe my first piece here is the leftmost piece. So remember, the leftmost section always starts when you're talking about intervals with negative infinity. Travels all the way to this x-intercept, which is negative 2.9. So my first interval, negative interval, would be negative infinity to negative 2.9. And then from there I have this other section that travels from here to there. And this x-intercept is negative 0.1, and this x-intercept is 3. And so that would be my interval, negative 0.1 to 3. So my intervals, my negative intervals would be negative infinity to negative 2.9 and negative 0.1 to 3. And so that is how I determine all these characteristics of a graph.